We are talking about we are working on chapter 5 on modeling, information modeling. And among them, we are talking about modeling. So what is modeling again? This is a system we are trying to represent or description or representation of a system, especially a software system. And at a high level of abstraction, it's an abstract model. Right? Modeling is an abstract model. So we call it as a model of the system, representation, simplification and abstraction of a model, a system. And this model is used for requirement and specification. You heard about requirements for industry in AP modeling, requirement. So ARM, you remember that ARM is trying to capture the requirement of the industry. A reference model and also specification. Our AP is a specification for industry usage of work. And it is necessary to model software system. Right. So it is about modeling, information modeling of software system. Usually, so if you want to develop a new AP, say something like automotive industry, you can collecting, say something like a special one. Say you want to make develop an AP for bicycle industry, and then there are already existing bicycle softwares for bicycle industry. So you can collect all of them around the world, or there are special experts on this bicycle industry can gather, and then they can collect all the data structure of this existing software. Data structure of the software, right? And then you can make them as a standard one. Okay, collecting, say, you are collecting all the industrial existing data structure of software A, software B, and software C, right? And then this can be bicycle system A, bicycle system B, and bicycle system C. And then is a data structure, all of them. And you can find a common set of them, or you can find a superset of them. Right? So in between minimum common set or maximum superset, you can arrive at standard set of data structure. Then you can see this, or call this one as a schema, standard schema or data structure of bicycle industry, AP for application protocol for bicycle industry. And then you can arrive at AP of that bicycle industry specialties. So modeling is related with this. Object-oriented modeling is related closely with them. In 1970s and 80s, it was popular in software programming, in structured programming, structured design of software, or structured analysis of software. But in 1980 and 90s, already 20 or 30 years ago, object-oriented programming or object-oriented design of software or object-oriented analysis of software is popular. So this is related with our development, because you see that STEP standard is developed since 1984. Right? Around that time, object-oriented programming was popular. Begin to popular. Now we are talking about Express. This is same material as I covered last week. So just remember this. The language, the information modeling, is for programming, and it has models such as entity, end of entity, and car model, and then supertype. And also it has entity and attributes for car model, car schema, or entity person, entity car. And you already see this one. And then the schema example shows a vehicle entity and car entity and truck entity. So it is a class hierarchy there. So among superclass of vehicle class, there is a subclass of car and truck. That can be captured as a express language schema. And that one is also written as a graphical notation of express G. Also, this part is covering about HTML or XML. This one is already covered in months ago. And when we talk about a standard for e-business, slightly covered. Anyway, HTML was the oldest one, and it is developed by for the military use in the United States for KAIST project. Military KAIST project. It is flexible but has a freedom, but it is not easy to use. You need to have a higher skill, and it takes time. So it was not convenient for ordinary people. And it comes with HTML. HTML is very simplified one, very simple version of HTML. It is only one fixed schema. We could say as DTD, document type definition. Only one. So you don't need to handle schema itself. You just use that schema. But it was very nice. It was very popular because of this simplicity, so that there has been many cheap browsers. Web browsers are popular because of the old people start to use HTML for developing their home pages. It was a very big success. And after 10 years of HTML success, people trying to have a little bit more capability than HTML, so that they develop a new language called XML. And XML you can design your DTD, or you can modify the DTD yourself. XML allows, but is in between of HTML and HTML, so that expressive power, XML is in between. HTML is most powerful. HTML is very simple, only one fixed schema. Right? But historically, HTML was the first one, and HTML was the second one. XML is the latest one. So it's a new development out of old technology. Right? But since then, web technology also improved much. Right? High-speed internet connection, hardware connection, or telecommunication also developed. So much has been changed. But anyway, in terms of markup language-wise, these are all in the same line or series. So XML is a short name of extensive markup language, and it was proposed not only 10 years ago, right? 20 years ago, right? 20 years ago, already long time ago, right? And that is developed by W3C consortium. That is a World Wide Web consortium, most popular now. And it is in between. It's a harmonization between HTML and SGML. Right? It is less capable than HTML, but it is more capable than HTML. So it's a trade-off between. So you can find more information from this. Today I'm trying to introduce UML and also some comparison or so the relationship between three languages. So UML is Unified Modeling Language. This is also very popular because of the object-oriented analysis and design. So it's a basically graphical language, so similar to Express-G. Starting from that one, but later stage they develop into more programming style coming from this, and this is helps to software developers, software designers, to simplify the complex process of software design. Because except Mohammed, you are not familiar with software design, right? But you can say that, or I can say that, software design is very similar to hardware design. You can think about designing a car or designing a ship, right? Or software design is there are many similarities between them. So you can think about the complex process of designing a car or designing a ship, right? That is similarity there. So you can use UML to simplify your design process of ship too, or car. Right? Anyway, so the UML diagrams has several kinds. Most well-known diagrams are use case diagram, class diagram, and sequence diagram. In terms of step or express, you can say this one is similar to AAM, Application Activity Model. So inside that there is use cases there. Class diagram is related with unit of functionality, UF, unit of functionality. That is inside the ARM. Reference model. ARM. So class diagram is related with ARM. Use case is related with activity model, AAM. And sequence diagram is also related with, in express terms, activity model. IDF has a sequence of process, so that they are mixing. So if they have more diagrams, collaboration diagram and state diagram things. So use case diagram shows scenario using that car or ship or building, right? And mainly used for capturing user requirement for software. Also, it is used for contact between software user and software developers. Or say you can car user or car developers. You can make match between software design and hardware design. So use case diagram looks like this one. Many inside that there is an actor and there is a use case. There is an action, say driving or parking or learning. Activities are there. So the user plays a respective system, and use case is a set of scenario that describing an interaction between user and system. And then there should be a system boundary too. In class diagram, class is very similar to related with object-oriented programming. And as I showed you before, that there is a class hierarchy, right? Class hierarchy, and there is a generalization and specialization in class hierarchy. And final node is, we say this is a leaf node as an object. So in object-oriented programming, there is a class hierarchy and then object classes or class hierarchy. So class is something like that one. You are trying to define a class in object-oriented programming. So and also this is related to ARM. ARM, unit of functionality. So describe structure and behavior of that object. That object is a car or human or ship. And it also has entities there. So it is used for requirement capture. And there's also detailed class diagrams too. More details. And simple class diagram shows a name of the class and attribute or property of the class and activities or operation. So object-oriented programming has a class definition like this one: name, property, and operation. Actions that can be used for. And then this comes to sequence diagram. We are example phone call. The caller, I'm calling a phone to recipient, and then I picked up dial, and then there is a dial tone is coming to me, and then I start dialing, and then ringing goes to recipient, and also ringing is inside this phone too, right? And then the recipient pick up his phone, and then communication can start. Right? This is very simple example of sequence diagram between classes. This is object. Class, between class, there is activities and sequences there. Right? And UML, SGML, and step relationship. The language-wise expressed in SGML is same. In terms of information schema, we call this information model, and in SGML, DTD is schema. And then physical level, the exchange level, there is a SGML document or HTML document or XML document there. The file itself, or there is a physical file or the step access interface by API. So you can have a translation between two steps. Now XML is popular, SGML is not popular, but there is a standard for step 2 XML translation there. Now return final section of relationship between them. This is coming from also more than 10 years ago. ASME is Association for Mechanical Engineers. Right? What is ASME? What is the full name of ASME? Mechanical Engineers. American Society. Really? All right. Society of Mechanical Engineering. There is a conference called Design Engineering, and that is presented by these people from NIST and Georgia Tech University, IBM, and NASA. And they're trying to capture the relationship between them. And in terms of Express and XML and UML, can you read this one? Is it large enough so that you can read? Okay. And there is a mapping language, and this is a real physical level, and there's party 21, and also there is a XML schema there, or DTD there, and UML also have a XML interface too. But in UML, you have a web services called Web SOAP, Web Services, and or WSDL. And in terms of standards, ISO step is popular for Express, but XML also have many XMLs, including also XML plant. This is plant industry. And then in UML, SysML is a system engineering that is also developed.
What do you mean by mapping language?
Mapping language, there is a special language for mapping to another schema. So between them, or between to another language, you need to have a special language for mapping.
So there is an XML to XML, an express XML mapping?
Right. Something like this one, right? This is step part numbers. Step part numbers. All step part numbers.
There is no express UML?
Express DOT? DD?
Express G to UML mapping?
Express G to UML mapping.
UML.
UML. I know there is a software, but there is no standard part for that. And then once again the same category as information modeling and implementation method and standard contents. And then they are saying step or express is good, especially in contents wise, but XML and UML is more good for modeling and implementation wise. Right? So they are suggesting that you can have a complementary strengths between that. So you can use XML and UML for modeling and implementation, but content-wise, because there is history of all implementation, so that step is more strong point there. And this is express language, as you see that simple. Sure.
In the previous slide, is there any detailed comparison between them, like this comparison based on other documents?
You can. I didn't see that, but you can go into extended version in journal of this paper. This is a presentation file. You can get this address. This is distributed already by email from me yesterday. There is a journal paper about this presentation. I hope you can find more details. And this is express schema for simple drawing, and also express G diagram version of simple drawing. And that one is also represented by XML format, right, for simple drawing. XML schema for simple drawing. Right? And there is a schema mapping between Express and XML. It is a part 28 of step standard. And also that one is same, the simple drawing object and class hierarchy is given by UML diagrams. Oh, there is having an Express UML mapping in step part 25. I cannot remember this one because maybe they drop out of this one. I don't know. Anyway, you can try to find out the old version. Anyway, you see that UML is very simple graphical notation, so they cannot contain all the details in something like XML or Express. Right, and then modeling languages, they are trying to separate out in schema level and instance level. And then there is a more constraint schema, lexical, and something like that. And also, they also touch on our language, XML language and UML language in the same level. And this step express is in a special, separate out into two different categories. In implementation level, step part physical file is there. But in terms of these languages, they also have implementation level things there. Right? As a final slide, they are trying to show the presentation of this slide is saying that they can be used as a complementary technology. So step is more strong point and contents model, and XML UML is more strong point in implementation. In the future of their work, they are trying to have a more comparison, and for the comparison you need to have a matrix. metric, the measuring information. And so that how much capabilities of expressive power each language has, or how good is in terms of contents level, and in the future they want to also include our languages, compare them together. All right.
There is no detailed comparison between all these languages already? This is the first time detailed comparison.
I guess because this presentation is 10 years ago, so you can find more. But not probably UML, XML, and OWL may be more comparison there. But express language is not many. So you can find out more and then tell me. Okay. All right. More question? No. Then we call 1, 2. Yubin. Oh, Ungsig is.
Okay, my lecture is about UML2 and XML2. The first is UML2. There is many UML modeling tool, but I will introduce to you 5 UML modeling tools. First is relational laws, and and second is UML Studio, and third, Microsoft Visio, Argo UML, and Style UML, sequentially in order. The first is relational laws. This is program of relational laws, and it have feature. Relational laws is an object-oriented unified UML software design tool intended for visual modeling and component construction of enterprise-level software application. A software designer uses relational laws to visually create the framework for an application by blocking out classes with actors, use case element, object and messages relationships in a sequence diagram using drag and drop symbols. Relational laws document the diagram as it is being constructed and then generate code in the designer's choice of C++, Visual Basic, Java, Oracle, and so on. And 2 popular features of relational laws are its ability to provide iterative development and round-trip engineering. And second is UML Studio. UML Studio, it is UML Studio, picture of UML Studio. And they have 7 features. UML Studio provides you with prepackaged industry standard notation such as UML, boot and data flow, and user-defined OA and D notations. UML Studio does not pursue you into using predetermined notation. And as a software professional, you know only too well that the needs of every organization project are different, and good communication often require designing new notations and create your own in a matter of minute or customize D1. And third one is generate documentation and code in your favorite language and create your own script to do what you want. Create and use libraries of symbols and design pattern, and you can use reverse engineer your legacy code into OO models in seconds. And finally, hyperlink object in your diagram to document or URLs. And third one is Microsoft Visio. It has 4 features. The first one is use pre-crafted structure diagrams and template, and plus thousands of shapes. And second is document a flow chart, create an organizational chart for your department, and map out your IT network and visualize your business process, and create a floor plan. And third is share historical and real-time data with individual or teams quickly and collaborate on the same diagram at the same time for almost everyone. And final feature is link shapes to multiple data sources. And first one is Argo UML. This is Argo UML's program and Argo UML's picture. And there is many features of Argo UML. It has all 9 UML 1.4 diagrams are supported and closely follows the UML standard. And export diagram as GIF, PNG, PS, EPS, PGML, and SVG. And it has extensible module interface, and Argo UML has many features. And finally, Star UML. Star UML has also many features. It is ERD support and fast modeling, retina display, and it's tension manager, model-driven development, and it offers open APIs, and it publishes HTML documents, and it has also disadvantage about, according to Wikipedia, sorry, it's not disadvantage. And next is XML2. There is 2 types of data files. One is binary files and the other is text files. And XML is a technology concerned with the description and structuring of data. Binary file is a stream of bits, and it is easy for computers to understand and best process, and it can be best processed. And next is text file. It is human readable file, and it has many applications. And like Notepad, it can read many of software files. And computer scientists need an ideal data format, binary files plus text file, and the result was SGML. The birth of XML is in 1998 by subset of SGML, and this is brief history of XML in this picture. And XML is a simple text-based format for representing structured information, document, data, configuration, books, transaction, invoices, and much more. And it is managed by W3C. And this is appearance of XML. The first is text file, and second is HTML file, and final picture is XML file. And there are also XML tools. The first is open document format for Office application. XML-based file format for spreadsheets, charts, presentation, and word processing document. And second is Scalar Vector Graphics (SVG). XML-based vector image. It is XML-based vector image format for two-dimensional graphics, and it is used in Mozilla Firefox, Internet Explorer, and Google Chrome. And third XML tool is mathematical markup language. It is MathML. It is XML for describing mathematical notation and capturing both its structure and content. It is used by Firefox, Explorer, Chrome, and Opera and Safari. And finally is X3D. It is XML-based file format for representing 3D computer graphics. It is X3D. It is form of X3D, and right picture is made by X3D. And this is end of my presentation. Thank you.
Yes, I'll start my discussion session. The first question is about XML and UML. XML means the structured modeling language, and UML means, as you know, a unified model language. And this kind of XML, the structured model language, was used in 90 or 80, and the UML is now using the language. So this is the what it is: the structural programming and about object-oriented programming. And this is the character of each language. Then you can read.
What is the stop code?
Stop means some like what is it? 그러니까 부가적인 뭐 어떤 코드라고 생각하시면 되는데, 또 사전에서 찾아봤는데 뭐 그런 뜻으로 돼 있더라고요.
Can you show us an example of XML?
Yeah. Yeah. this is the example of UML and XML. This is the same thing, but using different method. Upper side is UML and downside is XML.
This is a state machine diagram.
What?
The UML.
State motion? 그게 뭐지? So my question is this: what do you think about the differences comes from changing XML to UML? Just give your opinion. I don't know the answers.
What is XML? I haven't seen XML in the lecture notes. Is there XML?
No, but professor teach us about this presentation. This is the structure programming about, and this is object-oriented programming. And UML is based on the object-oriented programming, and XML is based on the structured programming.
The structure means in like
It is like
plus
no C. C. Object-oriented is C++. I think it is. Yeah.
Can you go back to the example, please? What kind of language is it? Second one?
What kind of language?
Yeah. Is it a known language? It's the SML language?
Normal language?
No.
Known?
Well-known name. Maybe this is not well-known because it was used in 880. So I think the programming language changed to object-oriented language, so we have to change the modeling language also. Yeah.
The only difference I can see is that the first one is graphical and the second one is more text-based. But both can convey the same information. So
The hint is XML is based on structured programming, and UML is based on the object-oriented programming. So from this basement, tell me your opinion about some differences between two languages. There is no answer, I don't know. So just give your opinion about this.
okay. As far as I understand, structured programming follows just like the sequence of functions. If you have functions and anything like that. It's like it does not try to combine the attributes or the variables into objects. So object-oriented programming came with this kind of thinking model for planning out programming. So you can divide the variables, and these variables belong to one object, and then you make an abstract design for the object, which is called a class. So combining the variables together and then attributing the functions to these variables, or putting functions inside some classes, that's the whole point. It's a organization for programming. But anything you do in object-oriented, I think you can do it in structure. It's just a lot more work. It's less organized. But yeah, I'm not sure how this relates to this example here. The first one is called state machine diagram, which describes how a class changes state, or a machine changes state, from first state to second state, and the trigger event, and this kind of information. And the second model seems to convey the same information. First state plus a certain event gives you a certain equals another state. It seems to convey the same information. I'm not sure how this relates to objects and classes, because there's no class diagram here. First one is not a class diagram. But yeah, if I have an opinion, that would be there's no other opinion I have.
Okay. I want to hear Wang Lin's opinion.
Oh.
As I understand, your thought is structure oriented language vs object oriented language.
Yeah.
But and it's just trend to object oriented language because structure. Now the structure also involve data and function, and originally only object can have both data and function. In that slide, object-oriented language don't need to additional code, right?
What additional code? About what?
That's right.
This?
You say stop code. Stop code is additional code.
Yeah.
I think it seems to not need to write additional code, but it can also add code, and I think UML is easier. I don't know exactly.
Yes, Wang Lin.
XML is quite similar to C and quite similar to C++. So I'm wondering how, like SML can, like you mentioned there, it can cover more complex extensions. Like as far as I'm concerned, I think like object-oriented programming can be more like extensible than the structure-based programming. So can you explain more about this more complex extensions?
maybe this is not compared to UML, but I think the other structured language, I think, compared to. But yes, I also think the object-oriented language, like UML, is more powerful to model some complex one. Yeah, so you can see this line. UML also can model the complex software system.
Yes.
Yes.
It can model the complex software systems. But for type modeling language, it can be more. It can cover more complex extensions. So that means like XML can be more powerful than UML. Am I right?
Do you have some evidence?
I have no idea because
Why do you think?
Because you said like XML covers more complex.
So what do you think about these more complex extensions?
Extensions?
Yeah. What is your opinion about this more extension?
I think like because UML is an object-based language, so it's not just like the C++. It has many classes, so it can be more extensible. But here you mentioned that the XML, which is based on object programming language, so like it's totally different from what I've mentioned before. So like here, the complex extensions. I have no idea. Maybe because it refers to the struct, only for the struct. But if we are trying to compare like which language is more complex, I think definitely like UML is more complex because like in the C++, we are comparing it with C language. So C++ like has a lot of classes, and then it also like encompasses like a basic struct which is inside the C. So I think here, like also like last one that covers sparse versions, like no, this comparison table, like here. So what do you mean by like the fault tolerant statements? Like last one, real time and fault tolerant statements. So it can be more like precise.
Precise. Like some error, some error things.
No, this is tracking type of system. Like transactional system is when you're selling or buying something. Real time system is something that's happening in real time. Fault tolerant like a machine that can have some triggers. If you put your hand, it turns off something like that. It's just different types of systems. But in a natural way, that's what you get.
Natural.
So next question. Expressed in step has more expressive power than UML. And do you think the perfect mapping between Express and UML is possible?
Why do you think Express is more expressive than UML?
Because last time Professor said it is more complex. So I think it can take more the data.
I don't think like Express can be more powerful even if it's more complex, it doesn't mean that it will be more powerful.
Is it wrong? The more expressive?
I don't think it is wrong, but I think the usage of those two languages is slightly different. Not exactly the same. But it's definitely not possible because these two are different language and different purpose. So any two languages cannot be perfectly mapped together. Or any natural languages or any computer interpreted language.
Ungsig is disagree side.
Disagree?
Yeah.
Maybe
Perfectly. Not possible.
say suppose express contains all the functions that are existing in UML, then UML can be contained, included in a way, right? If all the functions are covered by express, then from the perspective of express UML side, it is mapped to express 100%. But on the other side, it's maybe 30% mapping, right?
Yeah.
I don't know the exact functions of two languages, but I don't think perfect mapping between two languages is not possible.
How about the other side to Soonjo?
What did I do?
Yeah.
It's Soonjo?
Yeah.
Who is opposite and who is positive? No, the division of this question is
Yeah, Mohammed and Ungsig is same side, and
opposite side.
Wangning and Soonjo same side.
Opposite side means it is not perfectly mapping.
No, perfect mapping.
Why?
No.
Not,
I mean
not possible.
opposite to Soonjo.
So it's possible.
Yeah.
Without knowing the detailed features, it's hard to know. This is not I feel this is not a debate question. This is more of a technical question. It's a yes or no question. So, like UML is very powerful in the sense that it can support any type of program. If you can write a program, you can model it in UML. So it supports any of the programming languages data wise. And this makes it, I guess, descriptive enough or powerful enough. If Express has other features which cannot be expressed in presented in UML, then yeah, that would not be possible. But I think that's very hard because UML supports any type of program you can make. You can model it in UML. It has different dimensions. Like it has the, I think there's 6 or 7 at least types of diagrams inside UML, and they can be very powerful. But I'm not sure again if Express has extra information or not. Probably I'm not sure if it's a weakness or it's just lack of my knowledge, but the only thing that I don't think is well supported in UML is constraints. Constraints are not very well supported in UML. So maybe Express can be more powerful in resembling constraints and like solving them and checking them and so on. But apart from that, I'm not sure. I think UML is very powerful.
Yes, thanks. Time's over. Thank you.